All right, so now that we've kind of talked about the octet rule and how ions or atoms generally like to either get 8 electrons or they like to lose electrons so that they have this full valence shell, now we need to start talking about our types of compounds, okay? So one of our most common types is an ionic compound, okay? An ionic compound involves the stealing of electrons. All right. The big piece right here is that it involves the stealing of the electrons. So something is going to lose an electron and something else is going to gain an electron. Okay? So then we have a shared electrical attraction between the full positive charge and the negative charge. Okay? So our first kind of most common type is just going to be a metal that loses an electron to a nonmetal. So a metal, of course, we look at our periodic table and we say that it's all of our metals are below the staircase on the left-hand side. So that's going to include sodium, but it's also going to include iron, or it's going to include copper, kind of metals that we more commonly think about. And the metals, right, all of their electronegativities, the electronegativity is pretty low, right? They don't really like to hold on to electrons too much. So when it forms a bond, it's going to lose that electron fairly easily. Okay, so the ionization energy is really low. It's going to lose that electron really easily. So let's draw some. We're going to go over here. We're going to draw some of our Lewis structures for ions. Okay. So calcium, right? Calcium is a metal. It's over on the left-hand side. It's in the second column. So I'm going to draw my 2 electrons, right? My 2 electrons, though, I want to show that when calcium becomes an ion, it's going to lose those 2 electrons. So what I will do is I'm going to draw the symbol still. I'm going to put it in brackets and show that it's lost those 2 electrons. But I also need to put the charge on that symbol. So now here I've shown that calcium has lost all of its electrons and it has a 2+ charge. Okay? I can also do this for our anions, right? Our covalent in our nonmetals such as fluorine. So fluorine, if I were to just draw the Lewis dot structure of fluorine as an atom, I would have 7 dots around it. These 7 dots I know because it has 7 valence electrons. It is in the 17th column. Okay, so it's got 7 dots around it. It wants to gain 1 more electron to get up to that full valence shell. So fluoride ion is going to be F with 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. And now I need to put it in brackets and say that it's got a 1- charge. Okay? And this 2+ over here should actually be on the outside. I screwed up, I'm sorry. So my fluoride ion, what I can show here is that I have 8 electrons around it, and it has 1 more electron than it started with. So that means that it's got a 1- charge. All right? You'll also notice that I said it was the fluoride ion. So when we have positive ions, we're just going to say that it's calcium ion. It's just going to be that element as the ion. But when we have our negative ions, we're actually going to change the name from fluorine to fluoride. We're going to change the ending of the element to IDE to symbolize that it's the anion. Okay? So hopefully then we can fill in the rest of this sheet.